Guys, and welcome back. This is the video that will go with the Unit 6 Day 18 notes for the introduction to linear inequalities. And so after this lesson, you're going to be able to graph linear inequalities and then also find solutions on them. And so we're going to use Desmos again to help us. We're going to graph them, and then we're going to use the graph to determine solutions. So the first thing we need to talk about is what is a linear inequality? And it's just like a linear equation, only it has an inequality symbol instead of an equal sign. So remember, that's a less than, greater than, less than, equal to, or greater than or equal to. And then there's always going to be an infinite number of solutions. So whether it's on the line or not on the line won't always matter. It'll also matter about what side of the line it's on. So the solution is going to happen, it's going to be whatever ordered pair makes your linear inequality true. So when we look at it graphically, we can think of it as in these terms to help us. So remember that this is our less than symbol. This is our greater than symbol. This is our less than equal to symbol. And this is greater than or equal to symbol. So whenever we have a less than or a greater than, we get a dotted line. So they're both dotted. And then the solutions will either occur below or above. So below for less than, above for greater than. If the symbol is the less than or equal to or greater than or equal to, that means that there's a solid line. And your shading for less than will be on the line and below. Greater than your solutions will happen on the line and above. The reason this one is a solid line is greater than, equal to, less than or equal to, is because things that are equal to the equation will be solutions. Where if it's dotted, that means that your solutions are going to go all the way up to the line, get as close as they can, but they're not actually going to touch the line. The answers on the line will actually not be solutions because we're not including those points in our answer. So when we look at this example here, we're going to determine which ordered pair is a solution to the linear inequality. So all we're going to do is plug in for x and y in our equation. So we're going to have 2 times 2 minus 3 times 5. And we want to see, is that less than 15? So when we simplify this, we're going to get 4 minus 15. And then we'll have negative 11 is less than 15. Since that is a true statement, negative 11 is indeed less than 15, this is a solution. We can then plug in negative 1, negative 7. So again, plug into x and y. So 2 times negative 1 minus 3 times negative 7 is less than 15. When we simplify this, we get negative 2 minus negative 21 less than 15. Remember that double negative makes a positive, so negative 2 plus 21, which is 19, is less than 15. That is false. So this is not a solution. So if you end up with a true solution, or true statement, then you have a solution on your hands. That one is. If you end up with a false statement, you have not, then it's not a solution. And you would do the same thing for the other 2 points. If you wanted to graph a linear inequality, then you would follow by hand, you would follow these steps. You would write the inequality in slope-intercept forms. You may have to solve for y if necessary. You can graph the inequality using the table from above, and you would then graph the inequality and then use the table from above to help you know if your line is solid or dotted. And then you would use a test point. I always recommend 0, 0. It's a nice, easy point to plug in. You can get easy answers. And then if your test point result is true, then you shade that side of the line. If the test point result is false, then you shade the other side of the line. We will do a lot of mostly graphing from Desmos. So you can also use Desmos. All right, so let's do an example here. So for each line graphed below, determine which side of the line to shade, then state 3 points that are solutions and 3 points that are not solutions. So I have graphed this inequality for you already. Started at -5, we went up 1/3, just like normal. I see that I have a greater than symbol. So that means I want to shade above. I can also use my test point 0, 0 and see that 0 is greater than 1/3 times 0 minus 5, which gives me 0 is greater than -5. That is a true statement. So I'm going to shade that side of my line. 3 solutions would be any points in that shaded area. So 0, 0 we found to be true, and then any other point. So I could pick 5, 0. I could pick -2, -3. Those are all solutions because they're in the shaded area. If I wanted 3 non-solutions, then I could pick points on my line or not on or below the line outside of that shaded region because it's a greater than symbol. It's dotted, so the points on the line don't count. So I could choose as a non-solution 0, -5. I could choose the point 5, -10. I could choose the point 3, -4. Those are all points that are in the non-solution area. I'm actually going to make those red, pink, so you can see the difference. Okay. Now let's take a look at number 3. Y is less than or equal to -4. So I look down here, I want less than or equal to. So if I plug in my point 0, 0, then I get that 0 is less than or equal to -4. That is false. So that means that point is not a solution. So I want to shade the other side of the line. So I shade my other side. I can then go ahead and put 0, 0 in my non-solutions space. While we're there, let's go with some others. So another non-solution would be like 5, 0 or 10, 20, which would be over up here somewhere. If I want to look at some solutions, since my line is solid, I could choose a point on the line, such as 0, -4, or any other point, so 5, -10, or -5, -5. Those are all points that are solutions because they are within the shaded region or on a solid line. The last piece is being given a graph and being able to determine whether or not a point is a solution. So let's start with this one. So all you're going to do is I would plot my point. So I'd go 3, 4, 1, 2, 3, 1, 2, 3, 4, and say, is it in this solid area or on a solid line? It is, so I would say yes. And my reason why would be the point is in the shaded region. If I look at the point 2, 2, that is on the line, but my line is dotted. So that means it is not a solution because the point is on a dotted line. Let's jump down to this other example. So if I look at the point -4, 13, that's someplace well up here. That is very clearly not in the solution space. Your graph, remember, goes on and on forever in all of the directions. So you kind of want to use your big open brain there. So this is not a solution because the point is not in the shaded region. I look at the point 2, 0, it is a solution because the point is in the shaded region. They didn't give us this point, but let's go ahead and take a look at the point 2, 2. So if I look at the point 2, 2, that is this point here. That point is on the line. And since that line is solid, that means that that is indeed a solution. So the point is on a solid line. So remembering with linear inequalities, if the line is dotted, then the points are not solutions on the line, it's just in the shaded area. If the line is solid, then the points on the line are solutions and as well as in the shaded area. The thing to remember is that linear inequalities have infinite solutions, and these lines go on forever. So you do want to make sure that you're thinking about what is the trend of that line in that shaded area. I hope that this helps, and if you have any other questions, make sure to ask me in class. Have a great afternoon.